Today we are going to discuss a model designed to investigate the dynamics of hazardous weather communication and decision making. This model operates within the context of evolving hazard forecasts and complex model information environment. Developed through, interdisciplinary collaboration, the model incorporates extensive knowledge from fields such as hazardous weather forecasting, risk communication, information network vulnerability, and protective decision making. So, could you please introduce yourself before starting the conversation?
Sure. My name is Joshua Watts. I am currently the Cyber Southwest manager at Archaeology Southwest in Tucson, Arizona. It's a research-focused nonprofit, and a lot of my work involves integrating legacy archaeological data sets sort of to be leveraged towards sort of new research on archaeological topics. I got my PhD from the Arizona State University in 2013 out of the anthropology program. I'm an archaeologist by training. Did a postdoc which focused on hazardous weather, which is the main topic that we're going to be talking about today. And then, I came over to Archaeology Southwest in 2019.
So to start, can you explain the main purpose of this model and what inspired this? Its development.
I was going to work on this postdoc that was a collaborative with the Arizona State University and the National Center for Atmospheric Research, which is NCAR, which is in Boulder, Colorado. And the main effort of it was to work with folks in meteorology who were really comfortable with weather forecasting and all of the modeling and simulation behind weather forecasting, who no depth whatsoever in social science. And so they were not trained, not particularly well equipped to consider all of the factors that go into the decisions that people make when they are reacting to the weather forecasts that get generated. And so the specific topic we were working on was hurricane forecasting, acknowledging that in the modern world, partly because of climate change, we have a situation where hurricanes are more commonly, they rapidly intensify. So they'll, very late, you'll have these major changes in what the forecasts are. And then also we've just got considerably more threat from things like storm surge for low-lying coastal areas. And so the people I was working with were really interested in using the agent-based modeling toolkit to try to better understand how information about hurricanes moves through social networks, and then what is their decision-making process that basically would allow them to assess whether to evacuate or not evacuate. And so it was in some ways a realistic model in that we were trying to get population characteristics that were realistic enough to reflect the real population, but abstract enough that we were really just focused on how information flows and then how decisions were made.
Let's talk about the development process. What were some of the significant challenges you faced while developing the model, and how did you address them?
The group that I was working with was really interested in a sort of abstract conceptual model for how people process risk, and this is, I believe it was called the protection action decision model, and I can't really remember who to cite for that, but you got to imagine this decision model was kind of a very simple flow chart. It was a sort of thing that was just described, vaguely in like psych literature. And like my job was to try and turn that into like an actual block of code, that like the agents within this agent-based model would be able to process information and make decisions based on it. And so the both interesting and difficult part of this whole process was trying to implement basically a model that is just this vague flowchart on a page into something that would actually be instructions for agents to work with. And that just required a ton of sensitivity testing and just trying out different ways of parameterizing that part of the model and that kind of thing. But yeah, sort of, again, just getting from the abstract to the highly specific without much of a roadmap was really difficult.
So moving on to the findings, what are the key insights gained from the model analysis, and how do you, think they can enhance our understanding of hazardous weather dynamics?
When I would work with these forecasters on hurricanes, one of the things they would say over and over again is that, like, if you want to predict what's going on with the weather, like, build a statistical model, right? You look at what happened in the past, and then if you've got conditions that are similar, you can probably get a pretty good forecast for what's going to happen. If you want to understand how the weather works, like, you need to build from the ground up kind of a first principles model and sort of do something that's much more akin to like how an agent-based model works. And so in that they could have all kinds of molecules of air kicking around in a giant model that required a big computer in a basement run for days to come up with any sort of model of what's going on. And what ended up happening is, in almost all cases, the statistical forecast was going to be better than what you could get from the first principles model, at least as of 7 years ago. And so, what they were doing then was a different kind of exercise of learning about the system, more so than coming up with a forecast. And so my thinking about this model as we built it was much more like that second group of weather forecasters. We were really trying to understand sort of what things you could tweak within this system to get different kinds of outcomes, more so than we were trying to come up with a forecast for how people were going to evacuate when the next big hurricane comes storming into South Florida or something like that. And so I felt like the outcome that I don't know, if there's anything that I'm proud of about this, it was more in just building a framework for sort of testing different kinds of information networks, testing different kinds of decision models, testing different ways of distributing those kinds of properties throughout different agents in the model and that kind of thing. And so I think the model itself was kind of a cool contribution, but yeah, I think we were a long ways from doing like forecasting in the way that like somebody who was somebody who was a stakeholder or policymaker in Florida would have wanted from us.
Considering that you have made this model available on the ComSys platform, what were the main obstacles in the process of archiving this model there, and how did you overcome them?
I remember the feedback I got back was generally just mostly about better documenting the code, making sure your model description hits on certain points and things like that, all of which are pretty standard and fair, like in my case were relatively minor updates. So it was not so like it was a process. It was probably more painless than getting an article published, but more similar to that than not, I guess.
Also, I know this is about a few years ago, but looking ahead, are there any follow-up studies planned to build on this work?
So at this point, I'm not involved in it. This was when I left my postdoc, it was picked up by another postdoc who continued to add on to the model. I believe most of what that person did was just, for example, I had a system set up to import historical forecasts. So you could look at different hurricanes that happened 10, 20, 30 years ago and see how the agents I'd created would react to those different forecasts from the past. And I believe the work that Sean did when he picked this thing up was creating more inputs, so you could test a number of different storms, maybe some different geographic areas. Like when I was doing this, it was mostly focused on the Texas Gulf Coast and the state of Florida. And so he sort of just extended it. But I don't know how much he did with the actual mechanics of the way the agent-based model.
So thank you very much for joining me and sharing your insights on this model.
Yep. No, thanks for having me.